Today I'll be talking about chemical reactions, more specifically, how to estimate the products from when you have the reactants. So let's get started. So the first problem we're going to be doing is dilute sulfuric acid is added to a solution of barium chloride. So when it's dilute, it'll not be H plus HSO4, well, H plus HSO4 minus. Rather, it'll be H2 plus SO4 2 minus. And next thing we have is barium chloride, which is Ba 2 plus Cl minus, and there's two of them. So then what you get is that as you have the sulfate and barium, you have barium sulfate. Which is a solid, not a liquid. And so your equation would be H plus 2H plus SO4 2 minus plus Ba 2 plus 2Cl minus makes BaSO4, which is a solid precipitate, plus H plus Cl minus. Now, as you have H plus and Cl minus, you can just cancel them out as they're just spectator ions. They're not the main part of the equation. So it'll just be SO4 2 minus plus Ba2 plus makes BaSO4, which is the solid. So let's do another one. So this one is where we have chlorine gas, which is Cl2, is bubbled into a solution of potassium iodide. As the potassium iodide is Ki, Cl2 plus K plus I minus. And so what you're going to do is when you have these sort of reactions, it'll just be KCl minus plus I2. And so it'll be 2K plus 2I makes 2K plus 2Cl. So you also want to balance these out, and that's pretty easy once you get the hang of it. So as K is just like a spectator ion, as it's not changing anything, while the Cl is changing from Cl2, which is a gas, to 2Cl minus, which is different from Cl2. The only thing you have to take out is the 2 Ks. Oh, sorry, 1 sec. The 2 Ks, which is over here, and you just have Cl2 plus 2 plus 2I minus makes 2Cl plus iodate I2. So let's do another one. So this one, we have carbon disulfide vapor is burned in excess oxygen. So carbon has a charge of 4 plus, and sulfide has a charge of 2 minus. So it'll be CS2, with the S having a charge of 2 minus and the C having the charge of 4 plus. And it's burned in excess oxygen. So oxygen would be O2. So it'll be CS2 plus O2. And so as it's excess, which is the main thing that we're looking for, we can basically say that it's going to, so it'll be CO2 and SO2. The reason for that is because since we have excess oxygen, once the C and the carbon and the sulfide ions break apart, you can basically use extra oxygen to create CO2 along with SO2, so there's not much that's wasted. So now all we have to do is balance it. So CO2 and SO2. So there's one carbon on both sides, and then there's 2 sulfur over here. So CO2 plus 2 SO2, and now just check the oxygens, which is 2 plus 4 is 6, so it'll just be CS2 plus 3O2. So that's it for this one. So this one is a redox reaction, and redox reactions, hey, those tests. Anyways, so what we have over here is that we have tin 2 sulfate is added to a solution of iron 3 sulfate. So the sulfate, we can already see from here that there's spectator ions. So it'll basically be SN SO4, and just keep the SN here. So, and then actually, I don't think we need the SO4. So SN2 plus Fe3 plus. And as Fe is 3 plus and sulfate is 2 minus. So the only common number that they have is 6. So 3 times 2 is 6, and 2 times 3 is 6. So then what you have is that to balance this, you have to multiply both sides. I mean, you have to multiply the iron by 2. So SN plus 2 Fe3 plus makes, and so for this, you have to know your ions and you have to know what the charges can go to. So SN2 plus always goes to SN4 plus. And Fe3 plus or iron 3 plus goes down to iron 2 plus. So it'll be 2 Fe2 plus. And this won't work for larger redox problems, but for this one, what you can do with electrons is you can check the number of electrons. So you have 6 plus 2 is 8, and on the right, so 8 over here. And you also have 4 plus 4, which is 8. So check and smile, please. Yeah. So the answer would be SN2 plus 2 Fe3 plus makes SN4 plus 2 Fe2 plus. So that's it for this one. Next one. So hydrogen sulfide gas is bubbled through excess potassium hydroxide. So another fun one. So hydrogen sulfide gas is H2S. Potassium hydroxide is KOH. For all these problems, you do need to know your solubility rules. Otherwise, this is going to be a bit of a hassle. So now what you have to do is you just have to see that, like, so what you have is when you have H2S, it just breaks apart and makes HOH or water. So it'll be HOH plus And so you have a S, so the S becomes S2 minus. And the K would just be K plus. The thing with the K plus though is that you don't need it. So you just take it out as a spectator. So forget about it. Like pretend you never heard of it. So it'll be H2S plus OH minus makes HOH plus S2 minus. Or H2O. And now what you have to do is just balance it. So how much hydrogens do you have? You have 3 on the left and you have 2 on the right. So what you can do is you can multiply both sides by, well, actually, let's create a chart. So H, O, S, and then H, O, S. So you have 3 hydrogens, 1 oxygen, and 1 sulfide. So you have 2 hydrogens, 1 oxygen, and 1 sulfide. So what you have to do for this is that you just have to, so 3 and 2 have a common number that's 6, so multiply this side by 2, side by 3. So you have 6, 6, wait, what? Actually, 1 second, sorry, I made a mistake. So, sorry, so this will be, so this will be 3, and this will be 6, and this will be 2 times. Wait, so 3 times 2 is 6. Actually, no, this is 2. Yeah. This. Yeah, so it'll be 2 and I'm not sure. Yeah, so H, we have 3, so, oh, so we just have 2 is 4 and then 2 over here. So 4 plus 2 is 6 makes 6. Okay, sorry about that. And then you have 2 sulfides over here and then 2 oxygens. Now what you have to do is that you have 3 oxygens over here. So it just becomes a never-ending game. So I can come back to this later and we can get back to it, but that's the equation. So number 6, the gases boron trifluoride and ammonia are mixed. So BF3 plus NH3. So this one is pretty much like a trick question. Like you don't have to do anything special. It just becomes BF3 NH3, or you could do FE F3 B and H3. This reaction is not too special. It's honestly quite simple because when you have like a boron and you have like 3 fluoride, chloride, or any other like halogens, then you just have to follow this formula if you also have ammonia. So you're pretty much, this is like the same formula for if you have Cl3 or Br3. So so 2 more left. Okay, so for this, solid ammonium carbonate is heated. So when it's heated, this is like a decomposition reaction. So when something heats up, it starts to break apart. So it takes energy to break apart. So the energy is coming from the heat. So you have NH4. Two CO3. CO3 is 2 minus, NH4 is plus. And so once it heats up, so the first thing we have to see is what breaks apart first. So CO3 will always become CO2. And then NH4 will always become NH3. And so when NH4 becomes NH3, you have like two hydrogens because there's that 2 coefficient. So that 2H plus that O becomes H2O. I believe we balanced it already. It's all good now. So this is our final answer. Now let's do, oh, I guess that's it. Oh, okay. So I guess we're done. So I hope this helped out with reactions. So I'll be making more videos on that, as that seems to be kind of a problem in our class. Like our reactions are not, we're not that good at them. So, well, I guess that's it. So thank you very much and stay safe.